Okay, it's recording now. Okay, the next example, que es the number 2 example, totally completed, is que incluye everything, is this. F of x equal 2x squared minus 3x minus 5 divided by x squared plus 1. Okay, I need help. What is the first step to analyze this? Help me. Somebody. Participation. You remember 7 steps.
Express factor form.
Exactly. She said express it in factory form. Factory form. Well, those are factorization. I try to do my best. The factorization of the polynomial in the top. The factorization of the polynomial in the bottom. But when we start with the top, multiplication is 10. And the combination is obvious that 5 times 2, because 5 times 2 is 10, and somehow 5 minus 2 is 3. Then you copy 2x squared minus 5x plus 2x minus 5. This expression is equivalent because the only thing I did was you separate 3, negative 3 and negative 5 and positive 2. Now ready to factorization by grouping this couple and this couple. The great common factor in the first couple is x. We have 2x minus 5. And here is the great common factor is 1. 2x plus minus 5. Now 2x minus 5 I saw. Okay, it's a common factor, and the open new parenthesis, and the second parenthesis we have x plus 1. Everyone follow me in this idea? Everyone understand the factorization? Okay, this is the intermediate algebra, no? Maybe you are doing different like me, but the answer doesn't change. Okay, however, what's going on in the polynomial in the bottom, okay, it's x squared plus 1. This is typical irreducible quadratic. How do you know? Because it's plus. When it's plus, it's irreducible quadratic. If it's irreducible quadratic, unfortunately, we cannot factorization. It's prime expression. Leave it like that. No, this is the factory form. Any question, guys? Everyone? All good. Maricelis Benitez. All good. So you communicate using the chat. I can see the messages in my laptop. Okay, here no, because I have the whiteboard. So the whiteboard is over the sky. Yeah, I cannot see, but on the laptop, yes. Okay, what is the second step? Okay, I don't remember. Please help me. What is the second? What is the second? What is the second? What is the second? What is the second step?
Find the Y-intercept.
Exactly, very well. And what is the formula, miss, to find the Y-intercept? She said, find the Y-intercept. Because this is an important point, no? And what is the formula to find the Y-intercept? What is the formula? What is the formula? Nobody remember the formula for?
F 0.
Evaluate 0. Evaluate 0. So evaluate 0 is super easy because when you plug in 0, you replace x for 0, and the top stay alive only 5, negative 5. No? In the bottom 1, the answer is negative 5. Therefore, the point is the point 0, 0, 0, negative 5. You assume that x is 0. So x is 0, this is this consideration. And the answer of the y, que es the function is negative 5. This is my famous y-intercept. What is the third step? What is the third step?
Find the x-intercept.
X-intercept. And what is the formula for finding the x-intercept? What is the formula?
F of x equals 0.
She said f of x equals 0. Que es equivalent to say p of x equals 0. And p, remember, is the notation okay, we are using to denote the polynomial in the top. This guy. Okay? So it's super easy because you take 2x minus 5 times x plus 1 equal to 0. I take advantage, because this is already factory. You separate 2x minus 5 equal to 0 linear equation. Solution is 2x equal 5 divided by 2. X is equal 5 over 2. Okay, and decimal approximation, because when it's a fraction, no, it's better compared to decimal, is 2.5. Okay, conclusion, the x-intercept, at least one, is 2.5, 0. But we have another case, x plus 1 equals 0, negative 1. X is equal to negative 1, and so we have 2, negative 1, 0. Any question? This is classical, always is the same, 1, 2, 3. And the factory form, you see much better. And 2 and 3 is important point. At least we have in my hand 3 points. 1, 2, and 3 points. What is the number 4 step? What is the number 4 step? Help me, please.
Find the vertical asymptote.
Vertical asymptote, very well. And what is the formula for finding the vertical asymptote? What is the formula? I don't remember. Who remind me?
We have to make q equal to 0.
Exactly. Q is equal to 0. And Q in our problem is x squared plus 1. Okay, I saw before that this is a reducible quadratic, you know, but suppose that I don't know. I try to do my best and solve this equation. Entonces, I move negative 1 to the other side, square root both sides, and x is equal plus or minus I. And when it's something is imaginary or complex, it's because do not exist. Conclusion, this example have no vertical asymptote. We have no vertical asymptote. Okay? Keep in mind this, not always happen. So by the way, the domain of this function is all real number, because we have no holes and we have no vertical asymptote. The domain of f is all real number. But this is complementary. Domain of the original f of x is all real number. Because remember, the only possibility to be undefined is in the hole or in the asymptote, the vertical asymptote, the vertical, not the other, the vertical, specific at the vertical. So if we have no hole and we have no vertical, entonces the domain is all real number. Okay, what is the 5 step? What is the number 5 step?
Degree analysis to find out if we have a slant asymptote or a horizontal asymptote.
Exactly. She said degree analysis. Degree analysis allows us to determine if we have a horizontal asymptote or a slant asymptote. Let me copy the original. The original was f of x is equal to x squared minus 3 x minus 5 divided by x squared plus 1. Degree analysis, what is the degree of the polynomial in the top? What is the degree of the polynomial in the bottom? It's 2, no? In both cases. So I need to know by memory that when you have the same degree, yes, we have, no? Yes, we have what? Horizontal, no? Asked. Slant, no. Horizontal, yes. Okay, at what value? At, remember the dominant idea. What is the monomial dominant in the top? 2x squared. What is the dominant in the bottom? X squared. X squared cancel. It's 2. So add y equal to is the equation for the horizontal line. Okay. Okay, that's it. No. It's important when you determine the horizontal asymptote. So you need to verify quickly, of course, if the horizontal asymptote, or much better, no, the curve, the original curve, the original functions, cross or no, the horizontal. Sometimes touch, sometimes or cross it, sometimes no. The majority of the scenario is no. However, I need to verify. To verify, you take, again, one more time, the original function, and you enforce it to be equal to. Yeah, investigate see this equation have solution or no. See this equation have no solution, it's because never touch or never cross. In this case, well, I apply cross multiply. You multiply 2x squared minus 3x minus 5 equal time 1, no? Equal to time x squared plus 1. Apply distributing. Yeah, I can see. Okay, at least this part is cancelled out because it's the same term. And stay alive only minus 3 x minus 5 equal 1. Okay, so for x minus 3x is equal 1 plus. I make a mistake here. Hello, this is 2, no? Because you apply this distributive property, no? And multiply this times this, and multiply this times this. So this is no 1, 2. 2. Entonces 2 plus 5, que es 7, divided by negative 3. The answer is x equal minus 7 over 3. So I discovered that yes, my function at one specific point crossed the horizontal asymptote, and this point is obvious que es the point in negative 7 over 3 and x value, comma 2, que es the y value, que is the same y value of the vertical asymptote. And this is another important point. And frequently the student forgot this point. And this is important, extremely important. Okay, what is the number 6 step? What is the number 6 step? Symmetry, right? Symmetry. I copy again our original function. F of x is equal to x squared minus 3x minus 5 over x squared plus 1. Entonces, you don't need to do a super detail this idea because mentally you apply, you know, a quick analysis, and you know when the exponent is even like this or like this, stay the same, but when the exponent is odd, change. Entonces es 2x squared plus 3x minus 5 divided by x squared plus 1. And this expression is not the same of this, no. No, therefore it's no even, no even. And it's also no completely opposite sign, entonces nor odd. Entonces neither. It's neither. That means that I need to investigate separately the negative part and the positive part. Okay? Okay, entonces the super important moment to make a decision, what additional point, how many, professor, additional points. Entonces, my recommendation is you analyze the x-axis, is the domain, que by the way is a real number. I discovered, okay, unfortunately we have no varic asymptote. Okay, it's a good idea to make a partition here. The only possibility is the x-intercept. Okay, the x-intercept is located at the point 2.5, 1, 2, 3 here, 2.5. And -1 and -1. Entonces es good selection, for example, one point in this part. Maybe this is, this is 1, this is 2, this is 3, maybe 3, or maybe 4, or maybe 5, or maybe 6, any point. Give me the behavior of that part. I select 5. I select 5, totally arbitrary, and you evaluate the function in 5. This is easy, plugging in, replace x for 5, and the answer is 1.15. Okay, so I have additional point, is 5, 1.15. Then you plug it into the original with the calculator, either way. When decimals, after we see decimals. Okay, one more point is important, in my opinion. 1, I like so much 1. Okay, is in between. Remember, the partition was 2.5 and -1. So 1 is very, very representative of this interval. So you evaluate the function in 1. It's easy. The answer in 1 is -3. And the point is the point 1, -3. Okay, and one more, at least one more, case, before here -2, here -3, I select -3. I don't know why. So the function evaluate in -3 is 2.2. And the point is -3, 2.2. Okay, so we have enough information to make a very decent, nice graphic. 3 point, 4 point here. We have the horizontal asymptote, and we have 3 more points. Y-intercept, x-intercept, and another x-intercept. No vertical? No vertical. Okay, entonces I open Desmos. I dedicate my time, put the equation, the original equation, and you complement it with the auxiliary contraction. In this case, the only asymptote that we have is horizontal at y=2, and that's it. Let me see. You see them? Okay.
Yes.
I have here in the sample 6. I call 6. Boom. Look at that. Let me see in detail. And the green color, you can see -1 and 2.5 que es the X-intercept, 0, -5 que es the Y-intercept. Look at this is the Y equal to is the horizontal asymptote. And cross and the famous point que es -2.3 que es -7/3, ¿no? Comma 2. And 3 point additional, que in red color is 5, 1.15, 1, -3, and -3, 2.2. Super good. Any question? No problem. Do you understand very well? Sure. Okay. Yes or no? Answer me.
Yes.
Yes.
Good. Let's move on to another complete example. Remember the review packet, again, I come back to this part because this part is important in this chapter. Okay, let me know so you see or no whiteboard. Boom, boom, and boom. Do you see whiteboard?
Yes.
Do you see or no? Okay,
Yeah.
This is an x function I want to call h of x is equal to x squared plus 9x plus 4 divided by x plus 3. Entonces, I need help, guide me. Step 1, step 2, step 3. Please help me. I want everyone to be familiar with this guideline. And you apply always in this order, anytime.
Step 1, you factor, right?
Exactly, let's do it. Let's do it. Then you take the polynomial on the top. Okay, step 1 of factoring, 2x squared plus 9x plus 4. The multiplication, this guy and this guy is 8. And the combination is 8 times 1, because 8 times 1 is 8, 8 plus 1 somehow is equal 9. Then you copy this, get the first, and break it down, 9 using 8 and 1. This one is invisible, no? If you want to put, you want don't put, doesn't matter. Now grouping. Grouping this couple and grouping this couple. The great common factor in the red part is 2x. X plus 4. And the great common factor in the second is 1. Is x plus 4. X plus 4 is common factor. One more time, 2x plus 1. Okay, that's so far we have in the top x plus 4 times 2x plus 1 divided by, and the bottom is impossible to do anything because it's just one binomial. So stay like that. This is a factor of 4. And this is important because in this moment you see they are a common factor that we can simplify, cancel out in the top and the bottom. No, that means that we have no holes. Okay. Okay, everyone follow me so far? Yes or no?
Yes.
Excellent. Number 2 is the famous Y-intercept. And the formula is evaluating 0, the function. The name of the function is h. H and 0. It's easy because when you replace x for 0, in the top we have 4, and the bottom we have 3. Remember, it's countable. You don't express it like that. You put in decimal, 1.3 repeat. So the point is 0, 1.3 repeat, because it's easy to see graphically, no? Okay, and number 3 is x-intercept. X-intercept is the function equals 0. It's equivalent to say p of x equals 0, que is the top polynomial equals 0, But I take advantage that this polynomial is already factor 4. So it's easy. It's basically x plus 4, 2x plus 1 equals 0. I put each factor is equal 0. The answer is negative 4. Therefore, the point as ordered pair is negative 4, 0. And another is 2x plus 1 equal to 0 is 2x equal negative 1. Therefore, divided by 2 both sides. It's obvious that x is negative 1/2. And the point is the point negative 1/2, 0. Or negative 0.5, 0. In decimal. Good. How many points we have in that moment? We have 1 here, 2, 3. 3 points. Okay. Now, what's the number 4? The step I don't remember very well. Number 4.
Find the vertical asymptote.
Exactly. To find the vertical asymptote, you take the polynomial in the bottom, always q, and you enforce it to be 0. You take this guy. Look. This guy. So it says x plus 3 equals 0. Therefore, x is minus 3. Nice. So I put a dotted line. Okay, so far, I like so much in this moment, well, and doing a roughly sketch of the all real number line, the x-axis. Okay, I know that the domain is no all real number. It's all real number except negative 3, because it's undefined, because the vertical asymptote is undefined. And no whole, remember, infinity, negative infinity. It's a 0 in the middle, negative 1, negative 2, negative 3. And negative 3, we have 1 vertical, only 1. And we have also the partition of the x-axis. We have negative 4, negative 4, negative 4 is here, negative 4, 0, and negative 0.5, 0. Guess this. This is 0, this is negative 1, and between negative 1 and 0, in the middle here, and the midpoint is negative 0.5, no? 0. This gives me idea, after the last step, the partition of the x-axis, and give me idea how many additional points, in what position approximately, is located this additional point. Okay, let's move on to number 5. What is number 5? I don't remember.
Degree analysis.
Degree analysis to determine the horizontal or slant. In this case, I want to copy again. Our example is h of x is equal to x squared plus 9x plus 4 divided by x plus 3. The degree of the polynomial on the top is 2. The degree of the polynomial at the bottom is 1. Entonces now, what do you think? We have horizontal, we have slant, so you need to memorize the rule. No? Remember, I repeat the rule, we have horizontal when the degree is the same, or a special case when the degree of the bottom is bigger than the degree of the top. However, in that case, 2 on the top, 1 on the bottom, therefore we have a slant. Because we have a slant when the degree of the top is bigger than 1, the degree of the bottom. So yes, the conclusion is, the analysis is, yes, we have a slant. Obviously, we have no horizontal. And to find the equation for the slant asymptote, que es a line, pero no horizontal or vertical, no, es oblique line. What should I do? What should I do? Tell me, what should I do? Huh? Tell me, guys. What should I do?
We either do long division or synthetic
Long
division.
division or synthetic division. What do you prefer, Miss? What do you prefer? Long division or synthetic division? It's completely optional. We get the same answer, right? However, it's your decision using one or this or another.
Long division, so I can do better with it.
She won long division. Okay, let's do long division because she proposed me doing long division. So you divide this polynomial divided by this binomial. Okay. Well, it's obvious that the expression and the quotient here is 2x because I know that 2x times x is equal to x squared. This is the idea, the basic idea. And you copy 2x squared. And you multiply this and this now is 6x. And you put it here. Okay? Now, the division is the procedure que several times systematically you multiply and subtract. Therefore, I need to subtract. This is minus minus. This is cancel, que es the intention, and this is 3x. Y I finally bring down 4. Entonces es obvio que es plus 3, ¿no? Because 3 times x is 3x. And 3 times 3 is 9. Change the sign. Es negative 5. Okay, entonces I discover que this expression is equivalent to this expression, 2x plus 3 minus 5 divided by x plus 3. Unbelievable, but it's true. Okay, remember the formula is, okay, let me call name. This is quotient. This is remainder. And this guy, the name is divisor. And the formula is quotient. We copy here separately. Plus or minus, depending on the sign. Remainder, in this case, actually is negative 5 divided by divisor. Okay? This is the basically the only thing I can do is a manipulation algebraic. It's just algebra. And you discover, wow, this is my slant asymptote. So the equation for the slant asymptote is 2x plus 3. Okay. Well, as always happen when you have a slant or horizontal asymptote, you have to discover if the function, the original function, cross or no the slant. Well, to do this job, you enforce 2x squared plus 9x plus 4 divided by x plus 3 is equal to x plus 3. Okay, you enforce que sometime, I don't know, in one point I want to investigate the function is equal to this number. let's do it in a different way. I solved this equation, cross multiplication, blah, 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 blah. However, so you see here, this expression, when this original function is equal to slang, is because that part is 0. And that part is obvio que es impossible to be 0. Because the top part is 5. So we have no solution without doing anything. Do you understand this idea? Okay, this is equal to this if that part in yellow is 0. And never is 0 because it's 5, negative 5. Negative 5 divided by something is a number, never is 0. Remember, the fraction is equal to 0 when the top is 0. Suppose que I don't realize this idea. Okay, no problem. You, one more time, you solving this equation, apply cross multiply, 2x squared plus 9x plus 4 times 1 is equal to 2x plus 3 times x plus 3. And you FOIL, multiply. Is 2x squared plus 9x plus 4 is equal multiplication 2x squared multiplication 6x multiplication 3x and multiplication 9. Obviously, this part is cancelled because it's the same. So we have 9x plus 4 equal, we combine later, 6 plus 3 is 9x plus 9. Wow, again I can see this is cancelled and you get super contradiction. Completely false statement because 4 is not equal 9. It's exactly the same this interpretation. Do you understand that part or no? So what is the conclusion? The conclusion is the function, the original function, never crossed the slang asymptote. Never crossed. Everyone follow me, or you are totally lost?
Yes,
Clear?
we follow.
Eso. Bueno. After that, what is the next step? I forgot the symmetry, no? One quickly inspection symmetry idea. One quickly inspection. H of x is equal to x squared plus 9x plus 4 divided by x plus 3. One quick inspection of my function. I know when there is even exponent, 2 stay the same. When it's odd exponent, get 1 change. What do you think? No necessarily do too much. It's only inspection, visual inspection. What do you think? Is even as odd or is neither? Is even as odd or is neither? Even or odd or neither? What do you think? Classify my symmetric.
I think it's neither.
Absolutely.
Since the negative sign would be.
Yeah. The reason is when you make a reflection mentally, this stays the same, this change, this stays the same, and this is unchanged. They are twin brothers, no. Completely opposite sign, no. Another combination que is the most popular, no. This is special, and this is ordinary. Okay. There's no symmetry, therefore I need to select positive and negative value. As I come back, the last point, I now get additional point. How many points? In what location, what position? I come back to this. In this moment, I need to select. Remember, we have 2 points, this point, and one vertical asymptote. Would be fantastic. Select 1 point after. We have 0. No, 0 I have. It's the Y-Intercept. Remember the Y-axis, look at it here. It's the Y-axis. So I select arbitrarily. I select 1. Now let me use another color. I select 1. 1. Evaluate the function and 1. H and 1. This is maybe arithmetic is too hard, but you just plug in 1 in the original function, no? And the answer is 3.75. One more point. Well. I select. Let me see. I select, for example, -2 or -1. In my paper, I select -2, no? And H evaluated -2 is -6. And one more. Well, after, remember, we have the asymptote, we have the Y and X-intercept and -4, no? And -4 and -3. And -4, look, -4. And to see you select -5, maybe. -5. And you evaluate H and -5. And the answer is -4.5. Entonces I'm ready. I have 3 additional points. A ver, 1, 2, 3. We have Y-Intercept. We have 2 X-Intercept, no? And we have 1 vertical asymptote at x equals -3. And we have 1 slant asymptote at y equal to x plus 3, que the curve never crosses it. Okay, entonces now, with this information, I open Desmos and I see my curve. Let me try. Do you see?
Yes.
This is example 7. Look. Wow. Here in the left panel, you see the function. You see 6 points. And you see these 3 points first and 3 more. And this is the vertical asymptote. Look, I flashing that. And the slant. It's important to see that the curve never cross the slant. Okay, approach it, but never touch in both directions. Let me make a zoom in both directions. Super cool. Super cool or no? No? Clear? Confusing?
Clear.
Good. Very good. One more example, and that's it for that part. Okay. There you go. Okay, I want to erase the board. The last example is a little bit complicated, but I want to do. Okay, look, the function is name is g of x is equal x cubed plus x squared minus ax minus 11 divided by x squared minus 9. Okay, factor 4. Okay, and this is, no, I don't say impossible, but it's weird. X cubed plus x squared minus ax minus 11 is possible, but it's weird decimal. And I want to explain 2 different ways to find that. Don't worry, but for a moment, leave it like that. This is easy. This is the difference of a square. So for temporary, I don't touch this guy because the factorization is weird. My factorization is 3 plus or minus. Okay? And this is, you know, it's possible, 3 factor. But the number is weird. Decimal, decimal, decimal. Okay, so now leave it like that. But actually, I verify que es no equal, entonces no cancel out, entonces no holds. Okay. Find the Y-intercept is evaluating 0, and you evaluate 0. In the top, we have negative 11, at the bottom, we have negative 9. It's 11 over 9, okay, and decimal is 1.2, repeated. Therefore, our famous Y-intercept is the point 0, 1.2 repeated. Okay, to find the X-intercept, you need to solve this equation. And this is the challenge to solve. I want to explain 2 different ways. Of course, we need to use a software because it's very, very, very complicated. It's impossible. Impossible, no, but it's weird. It's complicated. Do it by hand. So now, one possibility is you put in decimals, and decimal is nice. Give me the X-intercept. So it's the point in which, let me show you a decimal first. And after I want to show you another software, fantastic software, que es Wolfram Alpha. So we are doing in both ways, using decimals first. After Wolfram Alpha, que es one software que es like a artificially intelligence to solve everything, any equation. Okay, and you need to learn this because when you take calculus, you need to be ready, no, for this software. But let's do in decimals, okay? You are familiar for the decimal first. And decimals. Here, over there. Okay, this is the previous example, and now this is the new one. This is the new one. You see here, look. Okay, this is my curve, blue color. Thus I see clear. Okay, we have, look here. You click on the curve and you see a gray point. And this gray point is important. They consider it, decimal consider it as important. It's important for different situations. In this case, if the X-intercept, look, it's minus 2.429. And you copy the piece of paper. And we have another, negative 1.3, 53. Entonces, guy, always we can do that. However, I explain in the other example different because in the other example it's easier. In this case, no, it's too hard. This is one Y-intercept, look. And we have here another. Let me make it zoom. Wow, look at that. Click here. 2.959. This is the. So I come back to the whiteboard. Yeah, I saw, or I determine my Y-Intercept, no? In this case, it was impossible by hand. Yeah, I determine case x equal negative 2.429, comma, x equal negative 53, comma, x equal 2.959. We're using decimals. Now I want to explain Wolfram alpha. Okay? When you cannot by hand, you using software. Everyone in the world using this software. Okay, Wolfram alpha. Let me show you Wolfram alpha. Where is Wolfram alpha? You open your Internet Explorer. Okay, let me see. Wait. You open. Okay, there you go. You open your Internet Explorer, the browser. I don't know what browser you use. Is it Safari or Google Chrome? I'm using Google Chrome. And you put Wolfram.
It's not showing the whiteboard.
No, because I tried to share the Wolfram alpha miss. Do you see Wolfram alpha?
Yes.
You put it here in the browser, wolframalpha.com. And you have here different subjects. Wow. Mathematics, science, technology, social, culture, every life. Wow. And I put in algebra. I go to algebra. Okay, I click in algebra. And the algebra, you can find equation solving, polynomial, rational function. Wow, fantastic. However, you select either box. For example, this. Okay, solution solving. And now, this is equation que Wolfram alpha bring default. But I change. I put my equation. No? My equation is x cubic power 3. It changed. Power 3. Plus x. On the power, you're using the key and the keyboard 6, but you press shift 6, no? The symbol can look like a roof of the house, no? Minus ax. Minus 11. Of course, I delete the rest. Checking see I am doing well or no. X cubed plus x squared minus ax minus 11. This was the polynomial. Okay, we can know factorization. Now press this button, look. And now the software thinking, and give me, wow, what the hell is that? Weird answer, right? I don't care this answer because you click approximate form, get the work I need. Boom, look at that, this is the answer. Exactly the same answer. Well, no, more accuracy. Negative 2.4292. The problem is actually this is the irrational number. That's the reason that the exact value is weird. And Wolfram alpha give me more. Give me the graph of the polynomial at the specific point. I suppose that this is the negative 2.4, negative 0.5, and positive 2.9, get close to 3. You know, using the symbol approximation. Good, very good. Okay, to say you never stop. See, you cannot but do by hand, Wolfram alpha. Oh, both. I want to do by hand and verify using Wolfram alpha or verify using this. Either way. Everyone understand very well? Sure?
Yes.
Now, let's move on to the whiteboard to continue the problem, no? Here, over there. Okay. You see whiteboard? Okay, so we have in my hand, one Y-Intercept and 3 X-Intercept, que es negative 2.429,0 and negative 1.53,0 and positive 2.959,0. Wow, we have 4 points so far. What is the next step? Help me. What is the next step? Help me, any help? Next step. I am a little bit lost. The first one was factor 4.
Find the vertical asymptote.
Excellent, very well. You want to enumerate 1, 2, 3, 4. 4 is vertical asymptote always. And you take Q. Q is x squared minus 9 and force it to be 0. Oh, and factor 4, either way, x plus 3, x minus 3. You solve the quadratic equation or you separate into linear equation. Negative 3. Positive 3. And as always, in this moment, this is the moment that I want. This is my style. I recommend you want to make a partitions of the ordinary number 1, and after we come back to this sketch to select the specific point, additional point, infinity, positive infinity. This is 0. Positive 3 and negative 3. Wow. 1, 2, 3. 1 vertical. 1, 2. Negative 3. Another vertical. Vertical to the 1. Vertical to the 2. It doesn't matter the name. We have 3 points more. The point is negative 2 point something. To say this is negative 1. This is negative 2. 2.4 is in between negative 2 and negative 3. Close. No, not close. Approximately in the middle here. We have 1 point here. 1.53 is in between negative 1 and negative 2. Approximately in the middle. We have another. And 2.959 is close to 3. You see in this smooth. Wow. So now you decide, for example, in my paper, I select, let me use that color, okay, light. I select 4 additional point. I select 2, why not 2? This is the minimum point. You see, you select more, much better, right? You select 2, you select 1, maybe. Sorry, this is 1. This is 1. This is 1. This is 1. I select 1. Or 2. Or 1 represents a different. Or 0. No, 0 no, because 0 I have here. And one more in the negative part, because by the way, that function is neither, right? It's obvious, no? It's obvious when you replace x for negative x, there are no symmetry. So you need to evaluate the positive part and the negative part. So I evaluate in negative 2 also here. So this interval I represent by 1. This interval in between this and this is select negative 2. And here, after the asymptote, negative 4. Okay, this is the minimum point. 1, 2, 3, 4. So negative 2, negative 4, positive 1, and positive 4. But this is the last moment. Okay, let's go now to the next topic, is number 5. Okay, number 5 is the degree analysis, horizontal or slant. Let me copy my function again. The name of the function is g, is x cubic plus x squared minus ax minus 11 divided by x squared minus 9. You copy in the original way or in the factory form, either way. Though they are not different in this case. Okay, now I do the, bueno, es obvio que the degree analysis, degree 3, and degree 2, no? Therefore, es obvio que es degree of the top is 1 more than the degree of the bottom, entonces es slant. No horizontal. Entonces we are doing the long division, o synthetic division, the way you prefer. Entonces let's do the division. X cubic plus x squared minus ax minus 11 divided by. Well, the answer is 6 because x times x squared is x cubed. And minus 9x. Minus 9x is here. I copy in this order, 9x. And this is completely missing. It says 0 x squared. And by subtracting, you change the sign. You change the sign, it doesn't matter here, but here it doesn't matter, it's plus. Because x times negative 9 actually is negative 9x, but by subtracting, you change the sign. Cancel out. This is x squared, because 1 minus 0 plus 0 is 1, plus x. Bring down 11. Negative 11. Next guy is 1 plus 1. Because 1 times x squared is x squared. And 1 times 9 is negative 9. But by subtracting it, positive 9. And we have no here, 0x. It's by subtracting, change the sign. I change the sign here, but not here, sorry. Cancel out. And the answer is negative, no, x plus 0 is x. And this is negative 2. And we stop here or we continue the division? How do you know that you stop? How do you know that you stop the long division? What is the clue?
We have to stop when the degree is 0.
No, no, exactly, miss. You stop when the degree of the remainder is less than the degree of the divisor. The degree of this is 1. And the degree of this is 2. And the majority of the problem we were doing before, the degree of the divisor is 1. Entonces you stop in 0 degree. Pero no, you stop in that moment. Therefore, my function g, the original was x cubic plus x squared minus ax minus 11 divided by x squared minus 9 is equal algebraically quotient x plus 1. And this represents the slant asymptote. Minus or plus remainder is x minus 2 divided by divisor is x squared minus 9. Okay, so I determined, wow, fantastic. My slant asymptote is equation is y equal x plus 1. It's too easy to do that. Slash. Okay, that's it. No, because I need to investigate if my function crosses the slang. Is this? In other words, this is a slang. See, my function cross. We have a common point. See, this is equal to this. That's because that part they put in red color now is 0. Okay? Therefore, you take that, or you set out the equation, it's more complicated, or you analyze this. See, this is equal to this. See, this is equal to this. It's because this is 0. And see, this is 0 is because the top part is 0, gets 2. And now in order to find the y value associated with that point, important point, you evaluate the function in 0. The function in 2, sorry. Plugging in, the answer is 3. And the point is 2,3. Wow, I get super important point. Super important point. How many points you have in total? We have in total a lot of points. We have 1, 2, 3, 4. We have slang. We have 2 vertical in 3 and negative 3. And we have a famous point. Entonces now, the only thing is obvious que no symmetric, neither. And the additional point que I evaluate was, okay, I come back to this sketch que for me is important, extremely important. And you evaluate G. You evaluate G and 4. Plugging in the original is 5.286. And we had the point 4, 5.286. You evaluate the function in 1. And 1 was 2.125. 2.125. There's 1, 2.125. And you evaluate in negative 2, no? Yeah. Okay, it's this guy, look, the selection. Is plugging in, you plugging in the original, no? Maybe, and using a calculator, of course. Is negative 0.2. Oh, easy. Negative 2, negative 0.2. And finally, in negative 4 is negative 3.857. The point is negative 4, negative 3.857. Wow. So we have enough information to put every information in our Desmos, right? Okay, I come back. Now Desmos. Oh no, because we have alpha and alpha. I need to switch into another window. Wait, cancel. Okay, another window. Pero call Desmos. Okay. Let me know if you see or not Desmos. Do you see them or no? Do you see?
Yes.
Okay, this is my curve. Look. This is the slant asymptote. Do you see how the curve approach seldom cross or touch and only one famous point, que is that point, 2,3. The point addition, and also don't forget the 2 vertical in positive 3 and negative 3. The rest is just the additional point, que es 4, 2, 1, -2, and -4. Wow, beautiful, fantastic. Do you like that? This is super powerful, right? Super, super, super powerful. So you have no excuse in the test. We go over again in the review package. But in the test, I don't complicate a lot of this. It's easy problem, and you destroy this problem, super. In the homework, in the test online, and Alex, I suppose you have no problem. Just in case, any question that you have, let me know. You communicate with me by email, send me the screenshot for the specific problem that you want can help you. Go to my tutoring service Wednesday from 11 to 4 p.m. Remember Jose Alegre, que is the assigning tutor for these classes. Whiteboard. It's okay, guys? Do you see whiteboard? Okay.
Yes.
Now, yes. Entonces now we start new topic. Okay, it's about polynomial. This is easy. I like this. Polynomial. Because we are strong, no? In polynomial and rational function. But it's inequality now. Inequality. Polynomial, rational, inequality. In basic non-linear inequality. And the solution is completely different to the linear inequality. Linear inequality, you apply algebra. In this case, you can, but it's complicated. Entonces, I propose one fantastic way for solving this, que is, let me explain, example one. Okay, you have, for example, x cubed plus 2x squared minus 3x greater than 0. Inequality. Solve this inequality. Solve. Remember the solution of the inequality is not equal the solution for the equation, because the equation is a point, 1 point, 2 point, depending on the degree of the polynomial. However, in this, no, we are looking for interval solutions. Okay, one bunch of value of the x can satisfy this inequality. Okay, guys, entonces I start. Always is the procedure is the same. I want to introduce little by little complication, but this is a straightforward example. Now, the only thing you should do is factorization the polynomial and the left-hand side. And the greatest common factor is x. So we have x squared plus 2x minus 3 greater than 0. I need to factor completed. Therefore, we have a trinomial. Yeah, I continue the factorization. X, and the combination is 3 and 1. No? 3, because 3 times 1 is 3, and 3 minus 1 is 2. And the sign is positive 3 and negative 1. Wow, easy. In this moment, when I finish the factorization, I enclose in the box this inequality, because this is an inequality I start working. I never use in my life the original. The original history. No good. Okay? Therefore, I'm using the new one, just a factory form. Okay, now what should I do? This is the beginning. You, in one corner of the piece of paper, you copy again this in factory form. And temporary, you consider it like equation. I know that the solution of this equation is not equal the solution of the inequality. No. But this helped me to understand this. Okay, entonces I saw factor by factor x equals 0, x plus 3 equals 0, and negative 3, and x minus 1 equals to 0, que is positive 1. Okay, I want to copy this, x equals 0. And this guy, the name of this guy is called critical value. This is the idea you see in calculus, always, critical value. What is the critical value? Critical value is you convert the inequality to equation and solve the equation. So what is the utilization? What is application of the critical value? Well, the critical value allow me create one graph. So in the test, I want to see one part is algebra and one part is graphic. And the last part is the table. So some people, I don't know, solving this in this stupid way is impossible. No. This is a special inequality. You solving one part is algebra, one part is graphic. Exactly, I want to explain now. This is my famous all real number line of infinity positive, infinity negative. And I take the critical value, 0 is the critical value, so I make partition, and this partition separate into interval, no? Negative 3 is negative 1, negative 2, negative 3. Another partition, and positive 1, another partition. So basically, the critical value help me to create 4 intervals. So this interval, this interval, this interval, and this interval. What will happen is if you have 3 partitions, we have 4 intervals. It's logical, right? And you now, using another color, you select one testing point inside testing points, plural, because there's several, inside each interval. For example, I select 2. The one is to say, no, professor, I want to select 3, or 4, or 5. It's the same, because belong to the same interval, therefore have the same behavior. So you select at least one, you get the behavior for the inequality in this interval. You select and between 0 and 1, suppose 1/2, or 1/5, or 1/3, or 1/4. And between 0 and negative 3, I select negative 1, or negative 2, whatever you want. And after or before negative 3, I select negative 4. This is the collection of the hour testing points. So what should I do with the testing point? Well, I create a table and testing each point one by one to verify okay, the point passing or do not pass the test. So I listing the testing point. TP indicate testing point. The testing point in my problem is negative 4, negative 1, out, positive 1/2, and 2. I repeat, the final answer is completely independent of the testing point you select. See, you of course select properly in each interval. Okay, and now you evaluate in the original or factor by factor. Okay, I prefer this easy. This x is this factor. After x plus 3, after x minus 1. So one column, I dedicate one column for the x, another column for x plus 3, another column for the x minus 1, and attach last column for the total. I want to call total because in the column of the total I summarize the sign, the information. Okay, everyone follow me so far? Almost we finish. Yeah, almost we finish. Now plug it in where? Plug in what value where and what expression? You plug in -4 in each expression one by one. But I don't want the numerical value. I want the sign. The only information in the inequality is signs. Sign we have two possibilities, no? Plus or minus. Entonces -4 here es obvio que es negative. -4 plus 3 es negative. And -4 minus 1 is negative. 3 negative. And 3 negative is negative. Yeah, I put a negative here because remember this negative comes from of the multiplication negative times negative times negative. So negative times negative times negative is equal to negative. Entonces it's easy because you have 3 negative and negatives. You have 4. Sorry. You have 4. 4 no, because maybe we have 4 because you have 3 factors. You have 2 negative and 1 positive. The answer is positive. It's easy. When you have an even number of negative, it's positive. When you have odd number of negative, is negative. This is important in this moment to understand that the control of this total sign is produced by the negative sign that you have in the row. 3 negative is negative, 2 negative is positive, 1 negative is negative. Let's continue. -1 es obvio que es negative. -1 es obvio que es positive because -1 plus 3 es obvio que es 2 positive. But I don't care the value. I care only the sign. Yeah, I put positive here. And -1, pero luego. -1 es robotic call. -1 and -1 is negative. Es -1 minus 1 is -2. No? Is this negative? Is this negative? Okay. Entonces we have 2 negative and 2 negative is positive. Entonces en this column, que es important column, I enclose in the circle. This is my style. Huh? You are doing it the way you would prefer. Okay, entonces 1/2 plugging in here is positive. Plugging in here is positive. And 1/2 minus 1 is negative. 1 negative is negative. And 2 is positive. 2 plus 3 is 5. And 2 minus 1 is positive. It's positive. Okay. When you finish the table, you almost finish. Because I come back at the beginning. Look, at the beginning. This is my original problem. Entonces I take a look that part. That part is greater than 0. That means it's equivalent to be positive. Okay, and you select in the table in the last part the column que contain positive. Okay, not always the same, of course, no. See, this problem I change. Suppose que I change here. No greater than, it's less than. Okay, entonces now the situation change is less than 0 and you select the negative I is the correct. Pero no, of course, I don't want to change the problem now. Hello. My original problem is greater than. But keep in mind that you take the right-hand side of the inequality, that by the way, always must be 0. Another example, no, it's not 0. So you need to have to be 0. But I know that the only testing point que pass the test is this guy and this guy. And this no, this failed. Okay, entonces the good guy is -1, pass the test, and +2 pass the test. Okay, I come back again to my graphic I see now que 2 pass. This is true. This is true. So this arrow indicate true statement. Of course, this is false, no? But I don't need to write that. I suppose que it's not true because it's false. Entonces, this interval is okay. However, look, the confusing part. 2 is one arbitrary value que I select inside the interval. Some students select no 2, select 3, select 4, select 5, and you get the same answer. However, our interval is extending from 1, get the critical value, to positive infinity. So this is my interval. Okay, by the way, continue forever in that direction and not include 1 is parenthesis. Because this inequality we are working is a strict inequality. I have no equal sign here. See, we have equal sign here. Then this problem is a combination of inequality and equation. And the 0 get the critical value participate inside the solution. But no, professor, don't change the problem again. Okay, this is a strict inequality and not include the endpoint. However, what is the other guy gets through? Es -1, que is belong to this interval E by the same reason the endpoint is not participate in the game. So what is my final answer, professor? My final answer is final answer. The final answer is this interval is from -3, comma 0. Unfortunately, we have 2 pieces. You connect them by or 1, infinity. End the story. Any question? Any question? Wow. Any question? Step by step. Factorization. Determine the critical value. Using the critical value, make a partition of the all real number line. Selection testing point. Plugging in factor by factor in the table. I create this table. You determine the signs. Depending on the problem, see the problem is greater than, you take the positive like a true. And the negative is obvious as false. No? Well, in this case, true both because it's, well, no, forget about this. And that's it, end the story. And the answer, when you contain several pieces, you connect them by union, no? So you copy, you listing every interval and connecting by union. Do you follow me? It's complicated, it's easier. Come on, any opinion? Any opinion? I have another problem and that's it.
Hello?
You hear me now? Opinion about the inequality. Do you understand or no? Do you hear me or no? Answer me.
Can you?
Yes,
Yeah, I can hear you. Can you hear me?
Okay. No. Opinion. I ask you opinion. Do you understand this inequality or no?
Yes, yes,
Okay.
I can understand it. Yes.
Okay. Just let's move on to the second example. And the second example, I want to complicate a lot of this. A lot of no, but introduce a new idea. Okay, new idea. Suppose example 2 now. And this is the last example for today. X to the 4th power. Yeah. Greater than or equal 4 x to the 2nd power. Solve this polynomial inequality. So far, polynomial today. After I promise that we solve the more complicated rational. It's a polynomial divided by polynomial. But so far, it's polynomial, only polynomial. Okay. The first thing you should do in this inequality, this example, sorry, bring me new things. The new is que es no strict inequality, es inequality and equation, que this is equivalent this or this. This is a new thing que bring me. Second idea que bring me this example is que right hand side is not zero. And this is extremely important, que right hand side is zero. Because in the table, when I finish everything, I need to detecting in the testing point who is positive, no? According to this idea, it's true. So mandatory, when you have a polynomial, you put the right-hand side must be zero. Yeah, you bring this guy, x to the 4th power, minus 4, x to the 2nd power, greater than or equal 0. Right-hand side must be 0. Maybe you see, no, this in this example is elementary, professor. No, in this example is elementary, but you forgot. I put a complicated inequality, and the first thing you should do is move everything to the left, because right-hand side must be 0. It's the level of the comparison. Okay, suppose que it's the level of the sea, and you need to determine if you are on the water or above the water, the level of the sea. Okay, this is extremely important. Now, what is the next step? Well, the next step is factorization. I focus in this polynomial, and I make a factorization. Break common factor is x squared. I saw here a difference of a square is 2. Okay, super. And this is my new inequality. Okay, by the way, is equivalent 100% to the original. It's equivalent to this. But this is ugly. Nobody can solve it in that way. However, everyone can solve it using that way. So the transformation is extremely important. Okay, what is the next step? The next step is convert this inequality to equation, because I need to find the critical value. Entonces it's a polynomial, degree 4. Actually, at the beginning is degree 4. Look at that. Degree 4. And we expect 4 solutions. No? The first solution is this, que es x equals 0, multiplicity 2. But I don't care, the multiplicity. No, I care. And the other is easy, is x plus 2 equals 0, x equal negative 2. Of course, multiplicity 1. And x minus 2 equals 0, x equal positive 2. X equal positive 2. X equal positive 2. Multiplicity 1 again. And this is the collection of our critical value. So far it's okay. And immediately I do the all random line. I make a partition using this value. This is my famous all random line. Infinity positive, infinity negative. We have partition in 0. We have partition in 2. And we have partition in negative 2. Perfect. Now immediately I change the color. I select testing point. Actually, we have 1, 2, 3, 4 interval. Maybe 3 is good. In that interval, maybe 1 is good. I like 1. 0, no, because 0 is critical value. I select testing point in between 2 critical values. Negative 1 is super good. And negative 3, or negative 4, or negative 5, or negative 1000 is a no, que represent that part. After the selection, I create my table to testing this point. Testing point is -3, -1, +1, and +3. Okay, the column of the table depending on the factors we have in the polynomial. This, and these 3 factors. X squared is one column. X plus 2 is another column. X minus 2 is another column. And remember, include one extra column in which you summarize the information. Okay, called total. This is a typical format for the table for solving polynomial and rational of inequality. Okay, therefore, I try. Suppose -3. Well, -3 squared is positive. It's obvious, no? -3 squared is 9. Don't confuse it, it's not -3 squared. This is different. Okay. Okay. -3 is negative because it's -3 plus 2, no? It's -1. Remember, I don't care the value, I care the sign. It's the only information I need to solve inequality. -3, -3 is -3 minus 2 is -5. It's negative. Entonces, in this row, we have 2 negative. The sign is positive. Guy, do you understand very well where come from these signs? It's clear?
Clear.
-1. Let's try -1. Wow, -1 here. -1 squared is positive. And you see, wow, professor. And then this completely column, regardless if it's positive or negative, is positive, positive, positive. Makes sense, right? Yeah, right?
Yes.
Entonces, entonces you explain, professor, que I don't care the positive sign and the information because the information I need is the negative. Negative times negative is positive, no? And negative times negative times negative is negative. And the positive, I don't care. Don't participate in the game. The positive is completely irrelevant, no? Therefore, I introduce a new idea that I want to practice next lecture. Okay, when you have factors that contain even exponent like that, you can delete totally that column. Totally delete the factor that contain exponent even, maybe 2, maybe 4, totally delete. Because the reason is clear. This factor is positive always and do not apport any extra information for this. The important for the solutions of the inequality is the factor, so mentally, if you want, you focus in this inequality. Now, this inequality, oh no, this is equation, sorry. This inequality is equivalent 100% to this. So the solution for this inequality and the solution for this inequality is the same. Okay? This is not too easy. I want to explain more detail, but not today. Next time. Let me finish this one. Okay, -1 is positive here. because it's negative 1 plus 2, ¿no? And negative 1 and negative 2 es negative 3 es negative. Entonces, 1 negative es negative. And 1 here is 1 plus 2 is 3, positive. And 1 here is 1 minus 2 is negative 1. Is negative. And 3 is positive. And positive. Because 3 minus 2 is 1, positive 1. Okay, the only, in this case, a coincidence. Not always happen. I promise that next time we analyze when it's less than what happened, but not today, is equivalent to say positive, no? So the true guy, get the solution is in the positive to say this is true and this is true. Not necessarily to write true, you put the check mark and that's it. So I saw que the testing point que passed the test is this guy and this guy. I select inside the line. Inside the line is 3 here. The interval is extending from the critical value gets 2 to infinity in this direction. Okay, super. Entonces now I dedicate the after si incluye or no the endpoint. I don't know. I am confused with that part. Another guy que pasa in the test is this, no? And this is tending from negative infinity or to negative infinity. And what about the point 2 and negative 2? Oh, 2 and negative 2 belong to the solution of the critical value. But remember, this inequality is not a strict inequality. It's a combination inequality and equation. And the solution for the inequality part I did before is the part I highlight in green color. But the solution for the equation is the critical value, que es 0, negative 2, and negative and positive 2. It's easy. You indicate que include 2 using a square bracket. But 0 is also one isolated point in the middle of the line. Wow. So what is the answer, Professor? Well, the answer is, let me show you. The answer is, is equal from negative infinity, comma, negative 2, bracket, including negative 2. To infinity. Or it doesn't matter. The order is not important. Union something, union 0, que 0 is one isolated point. And remember, in the equation, when you solve in the equation, solution set of the equation, you're listing like that, separated by a comma, and using the curly bracket like that, no square bracket. 1, 2, 3, 4, 5. This is a classical format for the solution for the equation. Union, the last part, que is bracket 2, comma infinity. Wow, amazing. This is the final answer. Final answer. Okay, entonces, this is complicated because involve a lot of details. Okay, detail is, well, not always the original inequality is given the nice way, no. You manipulate. What is the manipulation? To guarantee that the right-hand side must be 0. You factorization. And when you factorization, the factor que contain even exponent is totally deleted. Do not participate in the equation. Actually, I delete before because I know this principle. Yeah, I do not include this column. No, in the table. So my table actually look like that without this table. Okay. I do not include this. TP. -3, -1, 1, and 3. Boom. End the story. Only include the factors que have exponent odd number. 1, 3, 5, and so on. 2, 4, 6, no. Okay, the rest is selection the testing point, evaluating the each factor que stay alive. The factor que is cancelled, get delete, no. Do not participate in the game. And that's it. Do you understand or no? Clear or confusing? I promise next time we do the game all the time, solving complicated, and you know, delete, and sometimes partial delete, depending on the problem, so sometimes totally delete, like this example, that's clear, get totally delete, but another example, no, it's partial delete. Okay, guys? So you suppose que it's enough for today. Wow, our class is 2 hours, no?